Hello and welcome to this third feature engineering lecture in this course Mastering Artificial Intelligence. In this lecture, we will learn about how to select a subset of most relevant features. Now, what that is, the context, let's take a look at that. So, we started by looking at understanding the problem and data, exploring data, and then we did for the last section, last lecture, the feature engineering, where we generated a lot of feature options using the domain knowledge, you talking to experts, doing the combinations and polynomial, etc., etc. Now, having generated a large list of features, it's good to think of now selecting a subset of most relevant features because the feature engineering in the last lecture was more a brainstorming thing. Now you need to select a subset of what is most relevant features that will help you perform well on your models. So how do you do that is the question. So to select a subset of most relevant features that can help you reduce number of dimensions of your output variable in terms of number of features and improve model interpretability and performance, you can use many techniques. Now, what are the techniques that you can use? The first set of techniques is what is called univariate feature selection, in which you select features based on the statistical tests such as chi-square, ANOVA, and mutual information. And what these are, we will talk as we go forward. Second thing, what you can do is what is called RFE, recursive feature elimination, in which you iteratively remove the least important features. So finding the most relevant features are you can work on two sides. One, you can find out what are the most important features. Second, you can find out what are the least important features and remove and from your model. So that is what RFE is, where you iteratively remove least important features based on the model performance. And the third is what we've already talked about, is to assess the feature importance of the features using ensemble methods like random forest and gradient boosting that we've covered earlier. So these are the three ways you can use to select a subset of most relevant features, right? Right. So now let's look at how to select the features based on the statistical test. And there we will talk about, how can we assess the relationship between each feature and the target variable using the statistical measure. And there we're going to talk about three techniques, chi-square, ANOVA, and mutual information. So let's take a look at in a couple of slides as we go forward how to do that. So question is how to select the most important feature based on chi-square test. Any thoughts? So the chi-square test is used in statistics. All of you who have studied statistics would remember this. Is used to assess the independence between the categorical variables, two categorical variables. It measures the significance of association between a categorical feature and categorical target variable. So chi-square is to be used for categorical assessments. And how can you do that? So let's look at the commands that you can give in programs to do that. Now, in using a program scikit, sklearn features you can use to see the commands in which you can give first to choose the chi-square, import chi-square, and then you assume that X contains your feature, Y contains your target variable, and select 5 best feature based on the chi-square test. And the program will give you those 5 most important features. As simple as that. Thanks to these machine learning programs themselves, right? The second method you can use is ANOVA. ANOVA stands for Analysis of Variance. Now, analysis of variance is used, ANOVA is used to measure the significance of difference in the means of numerical features across different category of a categorical target variable. So it is the target variable is categorical, where you need to classify that, and the independent variables or features are numerical and they are from different categories, and how you need to find are there significant differences. And again, you can use the machine learning program from scikit sklearn, select so import F classification, and then as again you assume that you make sure that your Y contains the target variable, X contains your features, and then you compute ANOVA F values and select the best features based on the right F values. So that's how you can select the ANOVA also. Earlier, you had to do all the calculations yourself, but nowadays, thanks to this program, you can use that to quickly calculate these best features. The third one is to use the mutual information, and we talked about that earlier in one of the lectures. Now, the question is how to select based on mutual information. Now, mutual information measures a dependency between two variables regardless of their types, whether they're categorical or numerical. It quantifies the amount of information obtained about one variable through the so it just fits in terms of knowing how important is your feature for a target variable. Now, how can you do that? You see the program commands written here for scikit again in sklearn. You feature you import classif mutual info classif, and you again y contains target variable, x contains your variables or features, and you compute mutual information scores and then select the best features. And you use these commands. You can come back and look at these commands for your use later on, right? By downloading the PDF file. So having used these programs, then what you do is you evaluate selected features. So your selected features, either using either or more of these commands. So after selecting features using one of the above methods, you evaluate the performance of your machine learning model using these features, and then you cross-validate or hold out validation to assess model performance and determine if the model selection improves your accuracy or generalization. And you can use the program commands as shown here again in scikit-learn. Right? Then what you need to do is to iterate and tune the select the best model based on the statistical test. You need to iterate and tune. You iterate through different feature selection methods. Now, so you do iterative and tuning. You select through iterate through selected features, vary the number of selected features, and evaluate the performance of the model. Also, you need to hypertune or tune the hyperparameters and experiment different machine learning algorithms, basically to find the best combination for feature selection method, number of features, and the model type. So by selecting features based on the statistical tests such as chi-square, ANOVA, and mutual information, you can identify the most informative features that are strongly associated with the target variable, leading to improved model performance and interpretability. The other two methods, as we had started talking about, are recursive feature elimination, where you iterate instead of picking the top, the best or the most important features. Here you find the least important features and you remove them from your model, and then you see whether your model performance improve, and you do this iteratively. So the third method is to assess the importance of the features using methods like random forest and gradient boosting, as we had talked about earlier, and those could be used to determine the subset of most relevant features. So having looked at now come down from generating features to selecting, having a subset of relevant features selected, what do we do next? What we need to do is to then find the optimal number of dimensions or features in the feature space that can explain your output variable or target variables, and hence preserve as much information as possible. So minimax is the principle here. With minimum number of variable, what is the maximum output that you can explain? And that's what we will discuss in the next lecture. So thank you so much for watching this third feature engineering lecture. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question. And also download the PDF file to take a look at specifically those commands to use the statistical test.